Equations with two variables are a bit different than how we've learned how to solve equations with one variable. I'll tell you what I mean. Like but in the past we've learned 2x plus 5 equals 7x, and we've learned how to solve that. We know that we would subtract 2x from both sides, and we'd say that 5 equals 5x. We'd divide by 5, and we'd say that 1 equals x. Okay, remembering that, now kind of put that on hold and let's do something different. Let's say we've now got the equation y equals 3x plus 4. Now, what do I do to solve it? You can make up any number you want for our x value. Our x value is our input. Think about like on a coordinate plane, we'd say our x and then our y, correct? Our x is our, what's that called? Is it domain or range? It is our domain, right? Okay. Since we have this domain value right here, whatever we put in and then solve this will give us our y, which is our range. What I mean by that is I'll show you. Let's plug in a number for x, okay? And that's going to give us some number for y. So let's do it first with the number 1. Let's plug it in there. Now I would do that 3 times 1 plus 4. Well, 3 times 1 is 3 plus 4 is 7. So when I do that, y equals 7. Let's pick another number. Let's plug in 2. Do it again. 3 and then insert 2 plus 4. 3 times 2 is 6 plus 4 is 10. So when I have x value of 2, my y value is 10. Now, what I've done is create ordered pairs. As in, look right here. If I did this, doesn't that kind of look like if I said 1, 7 and 2, 10? Couldn't I graph those ordered pairs? Meaning if I made this, and let's say this was microscopically small, and I had all these awesome lines, and I said 1, and then this was 1, 2, 3, 4, 5, 6, 7. I ran out of space. Okay, there it is. 1 and 7 is right there. Now let's do 2 and 10. 2, and then let's keep going up. 8, 9, 10 is right there, so 2 and 10 is like that. Okay, these 2 points can actually be connected as in like a line. Now pretend that actually touched. I would do this better if I had maybe a ruler. But pretend there's a line there and that point's touching, right? Okay, that's a function. Those numbers that I have now in ordered pair, those are my solutions. Those are any values which make an equation true. That's called the solution. So 1 and 7 is a solution for y equals 3x plus 4. Also, 2 and 10 works for y equals 3x plus 4. Those are true values. Also, because I was able to connect those 2 points in a line, that is called a linear equation. I'm going to do another example of linear equation next. Okay, I have another equation there. I want to test to see if it is actually a linear equation and see if I can actually graph it. So I'm going to pick some values. Let's start with, I think it's always good to have a nice range, to maybe put a negative value, 0, and a positive. So at the minimum, let's do 3. And let's do -2, 0, and 2. It'll make sense in a second. So when I plug those in, let's start with -2. If I say that y equals 2 times -2 plus 1, well, 2 times -2 is -4 plus 1, y equals -3. So that's my value there. Now I'm going to plug in 0. Y equals 2 times 0 plus 1. 2 times 0 obviously is 0 plus 1. We say y equals 1. Now for the third one, 2. I'd say that y equals 2 times 2 plus 1. Well, 2 times 2 you should tell me by now is not 5 but 4. Plus 1 is now 5. So now I have 3 values there, and let's see if I can actually graph them. So let me move this over here, and I am going to make our little graph, our plane. Now, I'll make some values. -2, -3, 1, 2, 3. Let's go 1, 2, 3, 4, 5, and let's go 1, 2, 3, 4, 5. Let's go 5 always. How about that? Now everyone's happy. Okay, for the first pair, which was right here, -2, -3. Writing that out would look like -2, -3. The next one would be what? 0, 1, and then finally 2 and 5. Okay, let's graph those. The first one, -2, -3. So I go to the left, -2, then I go down, 1, 2, 3. So my point is right here, more or less. The second one, 0 and 1. Well, x is 0, y is 1. So I start at 0 and I just move up one space right there. Finally, for the third one, 2 and 5, I go x to the right 2 spaces, then I go up 5, puts me right here. Now, if I did this really well and I had this actually on maybe some graph paper and had a nice straight edge, these would be able to connect perfectly in a line, and that would make this actually a linear equation. And I have now graphed my linear equation. What that also means is that any number, any set of numbers, meaning any ordered pair, like over here I'd say that's at 2 and something, right? Anytime I find a number on this line, that x and that y value can be placed in for these x and the y values of this line. This is called the equation for that line. Okay, so let's try this again. This time I'll go a little slower, and I want you to pause if you need to. So we have y equals 3x minus 2, and we're going to graph this linear equation. So what we need to do is pick a couple of values. And if you remember on the last page, I said we need to pick a couple of values that may be like some positive and some negatives. I always think it's really good to do a couple of, at least 3 numbers. Why do I say at least 3 numbers? If you think about it, any 2 numbers will always be correct. As in, like, if I said a point here and a point here, this is a line. But if I said that point and then this point, this is also a line. This point and say this point, that's a line. Any of those could be wrong. However, if I had 3 points, there's only one way I can make a line, meaning point to point, I can always make a line between any 2 points, but not between any 3 points. Like there, I cannot make a line because those 3 points don't line up. They have to be in a row in order to make that line. Okay, so I cleaned that up. Now, let's pick those 3 values. Like I said, negative and positive. So let's do negative 2, 0, and 2. Now let's start solving by plugging in these x values into our x and determining what our y is. Okay, so if I plug in negative 2, so I say y equals 3 times negative 2 minus 2. 3 times negative 2 is negative 6, minus 2 is what? So I'd say that y is negative 8. If I plug in for 0, I'd say y equals 3 times 0 minus 2. 3 times 0 is not 1 or 15. It's actually still just 0. Minus 2 is negative 2. Let's do the last one. Y equals 3 times 2 minus 2. Well, 3 times 2 is about 8 or 9, give or take, and so we'll get the calculator. We should say that's 6. Awesome. Minus 2 is 4, so this value is 4. Now, like I said in the last one, I can, let me clean that up and move it, I can graph that. So let's do, let's see, I need the maximum of 8, so let's do 1, 2, 3, 4 over here, 1, 2, 3, 4 over here, 1, 2, 3, 4 over here, then let's go 1, 2, 3, 4, 5, 6, 7, 8. Okay, for the first value, I'm going to write them out again as ordered pairs. Negative 2, negative 8, 0 and negative 2, and finally 2 and 4. Now let's graph them. Negative 2, negative 8. So I go left 2 spaces, down 8 spaces, puts me right there. Now forgive me again for not being perfect with this, but I think you get the point. Next one, 0, negative 2. So x is 0, so we don't go left or right, and we just go down 2 spaces. So it's right there. Finally, for the third one, x is 2, so we move to the right 2 spaces, and then up 4 puts us like that. We should be able to make a line. Now, again, forgive me, that's pretty good. I think you understand that that is a line, meaning any number I pick for these ordered pairs, if I plug them in, I will get something that is an equation, or sorry, an answer to that equation.